Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with IgniteNet and EdgeCore. Today's host is Dan Kazwara, and he is their application engineer, and he'll be presenting today. If anyone has any questions, please submit them in the question box, and Dan will be able to answer them at the end of today's presentation. Dan, thank you so much for being with us here at Microcom today. We're looking forward to your presentation. I am finished for now. Please go ahead and take it on over.
All right, thanks Julie for having me again, and thank you everybody for joining today's webinar I'm going to host. Today's topic I'm going to talk about is mainly about 802.11ah, Halo, 900 megahertz. So I'm Daniel Kazwara, Field Application Engineer here at EdgeCore. And you're probably going to ask, why am I talking about this? And I'm from EdgeCore, so that's what today's webinar is going to be about. Okay, real quick, I'm going to cover 802.11ah. That's the main topic for today's webinar. I am going to go over a few other things. First is the Metrolink product line. That's the 60 gigahertz 802.11ad IgniteNet product line is end of life. I'm going to go over a little bit of that. A few new products, just a few, there's several, but I'm gonna cover a few new products that EdgeCore has. And then the main topic, the 802.11ah, Halo, and then at the end, Q&A. Okay, so if you guys aren't aware, the Metrolink, unfortunately, is end of life. There's no more chipsets available. The common question I get is, I have this radio, that radio, can I mix and match? You know, what can I do? I just need to get another, let's say a client went down, what can I replace it with? Okay, so common question is, will the ML1 work with the ML 2.5 model? And the answer is yes. The ML 2.5 is just a faster version of the ML1. The 2.5 standing for Ethernet port speed, and it does process the packets per second faster than the ML1. So if you have an ML1, you could put an ML 2.5 in its place. Now, the difference in distance is the same for the ML 2.5 or ML1. What determines that is the antenna. So if you have like a 19 centimeter, you know, it doesn't matter which model. If it's a 19, it's the same dB gain, it's the same EIRP. What I always say is a 35 can always replace a 19 because the 35 has more dB gain for distance. You could always replace a 35 with a 19, but you can't always replace a 19 with a 35, but sometimes you can. As far as the base station, those are client radios or point-to-point radios that I'm referring to here. Now when it comes to the base station side, there were three main models. There was the Omni, the ML 2.5 60 BF, 120 degree sector, and then the ML60 LW. Both of those are the 120 degree sectors. The ML60 LW is kind of like an ML1 version. Say it's like a 1 gig ETH port compared to the 2.5. Same thing, more processing power with the BF. So those are interchangeable as well with either subscriber, an ML1 or an ML 2.5 subscriber. So hopefully that helps a little bit. Now, is there a replacement? There is the Telegraph product line, but it's not a direct replacement in the fact that there is no 5 gigahertz failover with it, and they're not backward compatible with each other either. So that was a common question I get. But the CNLR, the MLTG CNLR, the Telegraph, is similar to a 35 centimeter Metrolink. Now, it doesn't have the 5 gigahertz failover, so you do have to pull in closer the point-to-point links. We recommend 1 kilometer or less, and maybe shorter if you increase the number of nines for reliability. But when it comes to performance, if you're looking for more packets per second, more processing power, the CNLR actually is about double even the ML 2.5. It'll do close to 3 gigabits aggregate, which is even better than the ML 2.5 was point to point. So you may want to look into that. The other advantage of the CNLR, it's similar in design of the 35, but it has a hood on the top to prevent snow, and also it has excuse me, that if you have more questions on the Metrolink product line, or if you have any questions on what you need to, what interacts with what, you're still unsure, just drop us an email at support@edgecore or edge-core.com. When it comes to the Terragraph product line, just drop us a, or you could check, actually, Microcom has a previous webinar that I did on, I posted, as you see on YouTube a while back, if you're interested in getting more information on the Terragraph. Okay, a couple new products I just want to cover. The ECS 1100 5P and 10 HP. So these are, you see the price point, they're aggressively priced smart managed access switches. The 5P, just 5-port, but it's cool. You see the price point's $149 and can be managed on EC Cloud, which is cool. And then the 10 HP is $329. That is high power. HP standing for high power. It's actually up to 90 watts. So, and a 250 watt power budget. So that thing is pretty powerful. So in applications where you need something like that. There's the ECS 4125. Actually, this has been out a little bit. It's not the new, it's not, let's say, brand new, where the other ones are pretty, the last slide, that's brand new. But this is cool because, 2.5 gig, people are asking, do I have a 2.5 gig ETH port switch? This we do, it's an 8-port here, and 2 10 gig SFP plus fiber ports. Also 60 watts, so it's PoE 802.3.8 or BT. Okay, also an SD-WAN, familiar. There's actually several SD-WAN routers available, but this one is the more like SMB WISP kind of one. I would say this kind of fits to the market. So I figured I'd cover this one today. There's 2 variants. There's the one with a 4G LTE module and one without. Now I'm quickly going over these. The AP111, it's now available, MSRP 149. It replaces the Spark AC1200. It's an indoor-outdoor Wi-Fi 6 AP that's IP55 rated. There's an OAP 101 6E. This one is unfortunately delayed. It's ETA is now Q3 of 2024. It's an IP68 Wi-Fi 6E. 2.4, 5, and 6 gigahertz outdoor AP. And the EAP 112. Now, this is where I'm alluding to or getting to now with today's webinar regarding 802.11AH and Halo AP. So this model, the AP 112 is a tri-band. Actually, it has 2.4, 5 gigahertz Wi-Fi 6 and a 900 megahertz 802.11AH chip. It's a Morse Micro MM6108 chipset in there. So kind of interesting, right? So in the IP65 rated, so the 802.11AH, it can be bridged on 900 megahertz. Okay, the channel widths of the AH are 1, 2, 4, and 8 megahertz wide channels with up to 21 dBm of output power, so a little over 100 milliwatts. And the speed or bandwidth on 900 megahertz is up to 32.5 megabits using an 8 megahertz channel. With a narrow channel setting, receiver sensitivity as low as minus 107 dBm, so it goes really low there. There's 3 variants of this model that there's going to be the Wi-Fi 6 with LTE, a Wi-Fi 6 with Halo, and then Wi-Fi 6 with Halo and LTE. As far as protocols and standards, it's Halo, Thread, BLE, Zigbee, Matter, and then optionally the 4G LTE. So lots of different things with this. Now, what is Matter? I want to cover that real quick. The Matter is not a protocol, but rather a home connectivity standard. So a EAP 112 can be used as a Matter gateway and controller. There's just a slide showing how this is kind of, the EAP 112 can kind of do a lot. There's even a thread border router, a Matter controller, so there's Matter supported devices. So Matter allows different manufacturers interoperability through the Matter standard. So that's the key. So they could still intercommunicate where the EAP 112 acts as the controller. Here's a deployment example with the EAP112. You can see different devices like Zigbee devices. It could be some Halo devices, some Wi-Fi 6 devices, and then even backhauling on the 4G, 5G LTE network. Now in this slide, you see, notice the Halo device, the camera. So there are, even using the Morse micro chipset, I've seen there's cameras out there with 802.11ah capability. And there is enough bandwidth to support even high definition cameras. I mean, it's not hundreds of megabits, but you don't need hundreds of megabits to support a few high definition cameras. So the advantage, of course, is using 900 megahertz. So you don't need line of sight. Deployment could be easier and placed in locations that are really not conducive for RF. And if you know, you dealt with putting things like, let's say it's a, you have a property, it's a large estate, and there's a long driveway and there's a gate at the end, and it's through a couple 100 feet away and through some trees, and it just doesn't work, but it's going to work fine at 900 megahertz, and you just need one good high definition camera that's going to work well, and it could be like a gate controller and things like that. So that's where this lower frequency stuff really can make things really cool for applications like that. Here's another example where you can, yes, it supports bridge mode on 900 megahertz. You can bridge to EAP112s, which I think is really cool. I mean, you can get really creative with this. A lot of bandwidth, no. Probably, I'm thinking with 32.5 megabits of PHY rate, it's probably around 15 to 20 megabits of actual throughput available. But you can think of many applications where you don't need a lot of bandwidth, you need coverage. And even 10, 15, 20 megabits is going to be very useful in a lot of scenarios where it's just that last area of coverage. You need a little bit of coverage. I could think campgrounds even, and just, like again, cameras and things, just stuff like that, or access control, just different things that I could see, you need a wired Ethernet going to something off that EAP112 too. You can do that. Okay, so let me go a little more into detail on this is the fun part so what is 802.11aah or Halo? So it's actually a standard, kind of like, well, Wi-Fi is, Wi-Fi Alliance standard. It's specifically though, in reference to sub 1 gigahertz, they call it the S1G frequency range. So in the US, that would be 902 to 928 megahertz. So, and if you're not familiar, people don't know, or don't really pay attention, there is an unlicensed frequency band, ISM band, that's 900 megahertz. There's we're familiar with 2.4 and 5. 60 gigahertz is also another one. Now 6 gigahertz has been more allocated to be, it's not really an ISM band, but it's designed for Wi-Fi. 900 megahertz has been there all along, and it really hasn't been used. It kind of was really popular, with cordless phones, and then it kind of went away. But its strength will be lower data rates and much further range, and it'd be perfect for IoT devices where high bandwidth is not required. And the claim is, and I'll go into detail of how this is possible, 10 times further range than 2.4 gigahertz Wi-Fi. There is also another technology 900 called LoRa or LoRaWAN. That actually has even further range than Halo does. But the thing is with LoRa, it's just super low bandwidth. I mean, the best I think I found is kind of doing research on LoRa. Looks like the best throughput or PHY rate is like 27 kilobits a second. So it's good for like just transferring information, like something had been turned on or off, or very basic communication, but it's not conducive for actual like usable like internet access or cameras or things that require hundreds of kilobits or a few megabits of connectivity. Now this is the channel allocation. There's basically for the current chipset available, and I believe Morse Micro is the highest throughput chipset you can get now for AH, and they have up to 8 megahertz channels. I think the standard supports up to a 16 megahertz wide channel, but nobody makes that yet. So you can get 26 1 megahertz channels, 13 2, megahertz channels, 6 4 megahertz channels, and 3 8 megahertz channels. So most likely you'd want to go with, using an 8 megahertz channel, and there's 3 to work with. Okay, so how does Halo go 10 times further than 2.4? Well, I'm sure you guys know, lower frequencies like 900 megahertz is going to do better, but 10 times further? Well, let me go over a little bit of how that could be possible. So there's 3 main things with radio in general that determine distance and range: the path loss, the obstructions, and the sensitivity. So I'll cover each of those. So the free space path loss. So there's a calculator there, everythingrf.com. You can calculate any free space path loss depending on your frequency. And 900 compared to 2.4 gigahertz has roughly about 8.7 dB advantage, or 8 to 9 dB. All else being equal, it's always going to be 9 dB better. Just because the frequency is lower, the free space path loss is better. It's lower. So let's just say 8 to 9 dB just by 900 megahertz alone. The other is reduced obstruction attenuation. So as you know, lower frequencies penetrate objects better. But one thing to keep in mind is that attenuation is additive, right? Not just one, but like if you have several walls you need to penetrate. So then it adds up. And you figure 900 megahertz is a really good frequency for industrial applications, lots of metal, things like that. So it has been used in that environment. And you could see, I say 5 to 10 plus dB. I mean, it could be way more than that. It could be 20, 30, 40 dB advantage over even 2.4, depending on the scenario. Like lots of metal, then the lower frequency can make a huge difference. So this could go well above 10 dB advantage, depending on the scenario. But the other thing to keep in mind is it allows for much more forgiving installations. You figure you could put, say, a 900 megahertz device in a less, let's say, ideal location, and it's more forgiving with still having a link. So that's another advantage. You don't have to be so particular in the placement of locations. And again, like when it comes to obstructions like trees and say buildings, things like that, walls, that's where 900 megahertz will shine. And then the RX sensitivity. So not only that, and this just has to do with the fact that the channel width is narrower with 802.11ah. So you can see here, and you probably want to see this. This is the MCS chart for 802.11ah, and you can see it does up to 64 QAM. You can see the channel widths are narrower. So as you narrow the channel width, your thermal noise floor goes down. I mean, you're narrowing the channel width means you're narrowing your filter of what you receive. And what you're receiving is the noise floor just becomes less and less proportionally. So there's actually a calculator for that. You see there again at everythingrf.com. You just put in the bandwidth, and the temperature is not that much of a factor. It's part of the calculation, but it's not a huge factor. The biggest factor by a large margin is just the fact that your RF bandwidth and your filter, how wide it is. And as you double your RF bandwidth, your thermal noise floor goes up by 3 dB, which kind of makes sense. So it gets 3 dB worse each time. So you see the thermal noise floor at 1 megahertz wide channel is minus 114. So that's the actual noise floor, the thermal noise floor. But what it'll receive at, you can see it's with a 1 megahertz with the, let's say, MCS. It's interesting, they call it 10, but it's kind of a special mode to get extra distance. It's minus 107 dBm. So you still need some SNR above the noise floor to receive it. That's why there's a difference there. But you can see it with that compared to Wi-Fi. A 20 megahertz channel width is minus 101 dBm. So if you notice with your Wi-Fi, you can't really connect better than about what, negative 90, negative 92. That's about as best as you could connect for Wi-Fi. So you can see advantage there. So with these 3 things, that you can get easily 20 plus dB of link budget over 2.4 gigahertz, and that's why there's just I like the 900 megahertz and 802.11ah reminds me of, it's just nice to have another tool, a different way The way I look at frequencies and technologies is like tools in a toolbox, right? You have your screwdrivers, you have your box wrench, you have your pliers. To me, it's another option, another tool for applications where I can now have this other way of linking over 900 megahertz now, bridging even, or have Halo devices now connect that also are 900 megahertz. And it's just a nice another option to have. So that's kind of the summary of today's webinar, and that concludes my webinar. So I'll leave it back to you, Julie, to see if there's any questions.
Thank you very much, Dan, for that wonderful presentation. And of course, I do have some questions for you. Let's get started with the first one. Here we go. What are some typical deployment scenarios where Telegraph devices excel?
I would say where there's high bandwidth requirements, like for example, like if you use the MLTG360, that has a 10 gig SFP plus input. It uses TDMA technology, so you can have 15, or high density also. You have 15 clients per radio, and there's 4 radios in that let's say 4 sectors in that radio. You could provide truly 1 gigabit per subscriber, with like a client node. So that's the strength of the Terragraph. Now, for point to point, like the MLTG CNLR, again, that's about 3 gigabits of aggregate. I think plus 1.8 gigabits in one direction it supports times 2, so up to 3.6 actually of aggregate potential throughput with that radio point to point. So that's kind of the strength of, say, that was kind of the application. High density, lots of connections when it comes to the base station side. That's kind of that's its strength.
Thank you so much for that, Dan. Let's go right into the next question. How does Telegraph support mobility and seamless roaming between access points?
Telegraph does not. So that's, and you wouldn't, I don't know if you're referring about Telegraph, that's 60 gigahertz. So you're not going to have, and that's pretty much a proprietary air protocol. So meaning it's just only other Telegraph products that are going to be connecting to it. So there wouldn't really be much mobility. I mean, it'd be limited mobility. There actually is some use cases where, say, cars that like driverless cars, let's say, could potentially connect and or buses download their information for the day and have a 60 gigahertz Telegraph client when they park, and then push all that data, several gigabits of data when they're done for the day. And then that's a use case scenario I could think that would be like somewhat kind of potentially sort of mobile, but not actual mobile, like a smartphone or something.
Thank you so much for that, Dan. Next question here. What are the future developments and enhancements planned for Telegraph technology?
I think for Telegraph, I don't know of anything that's really planned at this point. I think it's kind of where it's going to be. I know we're working on more detailed support on EC Cloud of the Telegraph existing product line, but not too much to announce. I would say that people don't know, but the CN does actually have base station mode. That was fairly new. And we may be working on having even base station mode on the CNLR. And people ask, well, why would you have base station mode on a CNLR? It's even though it's a directional subscriber unit or point-to-point radio, it's not as directional as the 35 centimeter Metrolink. The 35 centimeter Metrolink was a 1 degree beam, where the CNLR is 1 degree, but it has beamforming, and it actually can scan plus and minus 3 degrees. So it's actually a total of 6 degrees. So it's actually easier to aim. It's much more forgiving as far as installation. It can move a little bit and you won't lose your link. Let's say it was mounted on a pole that moved a little or it sways a little bit. But it also allows for even 6 degrees for point to multi-point in a limited scenario. So we've had people ask for this feature. So we are working on that. I'm not certain if we'll actually do it, but that's something I did hear about. We're going to try to work on doing. So figure if it's point to point or point to multi-point a kilometer away, your 6 degrees can go plus and minus a couple hundred feet to the left and right. So several buildings potentially. So, and base station mode on the CN or CNLR, if we do it, would be still it's 15 clients in TDMA. TDMA of 15 clients to the base station. So that is something I'd say that we are working on. That's kind of new, but anything substantial that's from compared to before, I would say not at this time.
Thank you very much, Jen. I appreciate that. Next question here for you. What kind of management and monitoring tools are available for overseeing EAP and OAP deployments?
Yeah, the main ones are that you have the, standalone, you can do that, but that's kind of limited. They support SNMP, so you could have your third party, SolarWinds or the Dude or things like that to monitor. But our EC Cloud is the most popular because it's next to free. Our EC Cloud it's free for up to 50 devices, and our cloud monitors. You can even set alerts for email notifications if the device goes down or some issue. You could change settings and also get notifications. So EC Cloud for sure is the way to go for, I'd say 95% of the deployments out there. That's the way to go. As far as EC Cloud costs go, if you have more than 50 devices, it's just $99 a year. So it's virtually free, especially compared to some competitors where they charge per device. It can get quite expensive. The other option is those models also, there is support for open Wi-Fi or TIP. So, and that could be a third party controller as well. So but that's a different part number. If you were to get that, make sure you order you'll always see the part number with a parentheses T for TIP. So that is a different, but those are basically the same hardware, but with different software in it from the factory. And so there's some options. So hopefully that answers that question.
Yes, thank you so much for that, Dan. Couple more questions left here for you. And here we go into the next one. What are the security features and protocols implemented in your EAP and OAP devices to protect against threats and vulnerabilities?
Well, I mean, as far as, the standard stuff that would be in Wi-Fi, I would say, if you're referring to the wireless side, is, WPA2, WPA3 is supported. You can do 802.1x radius. You can do that. So enterprise level security. That's pretty much standard, and that's good that it's a standard. That's what 802.11 is all about, is having the standards. It meets or exceeds any and all the industry expectations for security.
Thank you so much for that, Dan. Couple more questions here. Will all of your devices support 802.11ah or Halo?
Yeah, currently the EAP 112 is the first product. And if you saw, the schedule's a little bit out, it's Q4. So that's the first one. Will there be future ones? I'm gonna guess there probably will be. So EdgeCore partnered with the chipset manufacturer there, so Morse Micro. So I would expect that if Morse Micro has a future chip that's, let's say, a better version or something different, yeah, I mean, I could see that happening. But so far, yeah, just EAP 112 is the first one.
Thank you so much, Dan. Next question here. Can you give us an overview on the product warranties?
Yeah, I believe, let's see if I remember right, the IgniteNet had 2 years, the EdgeCore enterprise stuff has 3 years. So that's kind of it. Now I believe there's some that have 2 years, so I apologize. There's some that do, but I believe it's between 2 and 3 years. I got to double check that. For some models, I think it's 2 and the others are 3.
No problem. Obviously, when folks buy, they'll know what they're getting and the warranty information that comes along with it. Last question. Can you give us an overview on where your products are manufactured?
Oh, well, Taiwan.
Okay.
Yeah, that's simple. I mean, EdgeCore is a Taiwanese-based company, so yeah,
Oh,
that's an easy one.
okay. There we go then. That's perfectly easy. And thank you so much for that, Dan. And thank you for answering all of those questions for us today. And of course, a very big thanks for those attending today's webinar. And if anyone has any further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown here today, please remember that this webinar presentation has been recorded and will be uploaded to Microcom's YouTube channel so we can all view it again. Dan, I appreciate your time, all the information you brought to us today. So please go ahead, everybody. Excuse me, and have a wonderful day. And thank you for being on our webinar. Take care, Dan. Hope to see you or hear from you again very soon.
Thank you.
Bye-bye.